Okay, geometry students, we're going to be talking about special right triangles. Hopefully you can hear me better now because of the fact that I turned up my microphone. We had some issues with the last video, but I'm sure you can hear me pretty loud now. Okay, now the special right triangles we're talking about are going to be what is called a 45, 45, 90 degree triangle, and also what it was called a 30, 60, 90 triangle. Now, a couple things I want to make sure we're clear of is that we're talking about right triangles, which means you're still dealing with right angles for both of these, okay? So also the Pythagorean theorem also still is in play here. Okay, it still is in play, but because of the fact that these are the special right triangles, there's actually a couple of relationships that you can work with uh, outside of the Pythagorean theorem. So let's go ahead and deal with the 45, 45, 90 degree triangle. Okay, now let me just kind of put some geometric symbols in here just to kind of help you. If I was to do this right here, notice the two tick marks, you would say that I have an isosceles triangle. Isosceles triangle is when you have two angles exactly the same. Well, this is a 45 degree angle, and this right here would be the 45 degree angle because remember all true triangles add up to get to 180 degrees, interior angles that is. Now, there's a relationship here, okay? And that is my two legs will be exactly the same. So I'm just putting some numbers down. If this was 5, this right here would also be 5 because these are my two isosceles congruent sides, okay? So at this point in here, you can actually do the Pythagorean theorem if you wanted to. But if you wanted to deal with the relationship and that the relationship between a leg and the hypotenuse is that you take the leg and then you multiply it by radical 2 to get the hypotenuse. So without even using the Pythagorean theorem, using this relationship, I could just multiply radical 2 to this leg. So that means my answer would be 5 radical 2. There's my answer. Okay? So let's try this again. All right, let me clean this up a little bit so I can actually have some room to write. So let's say, for example, I have a leg which is 4 units long. Well, I know that this leg here would be exactly the same because it's an isosceles, but then from my leg to my hypotenuse, I would multiply radical 2, which means my answer would be 4 radical 2. Now you might be saying, Coach Ford, I don't necessarily like dealing with radicals, and we haven't dealt with radicals this semester, so that feeling is justified, so to speak. So if you're ever dealing with a situation where I have a radical where I want you to convert to a decimal, then what you're going to do is you're going to say, this is actually 4 times radical 2. So in your calculator, do radical 2, which gives you 1.41, and multiply that by 4 to convert it over to a decimal, and you would get roughly 5.65. Okay? Now, this relationship is also the exact opposite way. If rather than giving you a leg, I was to give you the hypotenuse. So let's just say I gave you the hypotenuse, and let's say it was 9 radical 2. Well, in this case, rather than multiplying, you have to do the exact opposite, which means you would be dividing by radical 2. So when I take 9 radical 2 and divide it by radical 2, basically the radical 2's get canceled, so that is dealing with 9 and 9. And there's your answer. So let's go to a couple work problems. Oh, here you go. Let's look at question number 1, we're dealing with a radical. So I'm just trying to get us something simple at this point in time. And okay, let's look at question number 5. Now remember, you guys can pause this video and you can work on any problems you see that you think will help you because of the fact that I'll show you the key afterwards. All right, we're dealing with a 6. Now I know because of the placement of my right triangle that 6 is the hypotenuse. So to get to the hypotenuse back to the leg, I'm going to divide by radical 2. Okay, now because of the fact that we haven't really dealt with radicals in this class, I'm just going to convert radical 2 to a decimal and then just divide it out. So that would be 6 divided by radical 2 as a decimal. So let's see. Radical 2 square root is 1.14 roughly, and then divide that by 6, I would get 4.24. So that means this leg would be 4.24, and this is I'm sorry, an isosceles triangle, so this right here would be 4.24. There's your answer. Okay. Now let's look at problem number 4. We have 3 radical 2. Well, 3 radical 2 is a leg because the placement of my right triangle, this is a hypotenuse. So if this is 3 radical 2, you know this right here will be 3 radical 2. Well, you might be saying, well, Coach Ford, I don't like dealing with radicals again. So I'm going to take radical 2, and I'm going to multiply it by 3 to convert it to a decimal, which the decimal conversion would be 4.24. Okay, which means this right here will be 4.24. Now I need to know what my hypotenuse is. Now once again, you can use the Pythagorean theorem if you want to. A squared plus b squared equals c squared. You can do that, but let's just go ahead and go off the rule. So if I was going to go to a leg to the hypotenuse, I would multiply by radical 2. And that is multiply, not x. So I would take 4.24 and then multiply it by radical 2 to get my answer. So when I do that, I get an answer of 6. Now, depending on how you round it, it might be roughly 5 point something, or maybe it was 6 point something, but the answer is 6. All right, let's look at question number 2. Once again, I'm dealing with a 45, 90-degree triangle. This 4 is the hypotenuse. I have got to get to the leg, which means I'm going to be dividing by radical 2. So when I do that, 4 divided by radical 2, I get 2.28, which means if my leg is 2.28, once again, 2.28 for a decimal. So that is a 45, 90-degree triangle. I'm going to scroll down through this key. So if you'd like to pause anytime throughout this video, feel free to do that. All right, now questions 7 and 8, we're dealing with a 30, 60, 90, and that'll be on the next video. So we're going to hold off on question 7. We're going to hold off on question 8. Let's see what the next page. All right, question 9, 10, 11, 12. These are all 30, 60, 90s, which I'll teach you. 13 you can do. It's a 45, 45, 90. All right, remember, just pause the video. That's fine. No problem whatsoever. All right, here's the answers. Okay, as you're working through these problems. Now, they are converting some of this to radicals, so if you need to convert it back to decimals, feel free to do that. You should know how to do that at this point in time. Okay, so there are all my answers here, so check your work as you're going through it. There you go. That's all my answers here. There's all my answers. Good, good. All right, you're done. So the next video, check it out, is going to be on 30, 60, 90 triangles, and once you do that, you would be done with these lessons. Thank you.